In section 3 of module 5, we are going to look at applications of systems of equations. So what that means is modeling a situation with a system of linear equations. It's word problems. So the most important thing when you're modeling with a system of linear equations is identify your variables. If you don't know what your variables are representing, it's going to be very hard to come up with the equations in order to know what you're solving for. So you will be creating two equations which you'll then solve, typically using substitution or elimination. Very rarely, if ever, will we use graphing here. Because you get to choose your variables, you're not always guaranteed to choose X and Y, which means you have to choose one to be your X axis and one to be your Y axis. It just makes things a little bit more difficult. So we are going to solve these using algebra and not graphing. Doesn't mean you can't graph them, but it's not the common way. So first application problem we have is that Jim needs 320 feet of fence to enclose a rectangular lot. He knows that the length of the lot is going to be 40 feet more than the width. So we need to know the dimensions of the lot. So basically we need to know the width so we can do our dimensions. So my variables, I'm going to use L and W. L is going to represent my length. W is going to represent my width. So important thing to know here is if we have a rectangular lot, what's the formula for the perimeter of a rectangle? So formula for a perimeter of a rectangle is 2 times the length plus 2 times the width. So we know the length and we know the perimeter. So the perimeter is 320. The length is 40, so 2 times the length plus 2 times the width equals 320. We also know the length is 40 feet more than the width. So it also tells me the length is 40 plus W. So whatever the width is, if I add 40 to it, it will give me the length. So the way I've set up, the way that this question is worded, it's set up perfectly for substitution. I'm going to take my 40 plus W and plug it in for L in my equation. So we're going to 320 equals 2 times 40 plus W plus 2W. Distribute the 2, you get 320 equals 80 plus 2W plus 2W. 320 equals 80 plus 4W. Subtract 80. So you get 240 equals 4W. Divide by 4, and my width is going to be 60 feet. So that tells me my length, which is 40 feet more, is going to be 100 feet. So my dimensions are 100 by 60. And I can always double check this by plugging it into the formula for perimeter. So 2 times the length, so 2 times 100 is 200. 2 times the width, so 60 times 2 is 120. And 200 plus 120 is 320. And I already know my second equation is met. So these are the dimensions for the rectangular lot, 100 feet by 60 feet. So next we have our distance and time. So 2 trains leave Tulsa, one going north and one going south. After 4 hours, they are 376 miles apart. If one train is traveling 10 miles faster than the other, what is the speed of both trains? So first thing I have to do is label my trains. So I'm going to let N be the northbound train. And S will be my southbound train. Important formula to know here It's a science formula. It tells us the distance that you travel is directly related to the rate at which you're traveling and the time that it takes you to go that far. So distance equals RT. So that's what I'm going to be using to construct my system of equations. So we don't know the rate at which our trains are traveling. We know the amount of time that has lapsed. We got 4 hours for both, and we know that the distance that they have both traveled is 376. So my first equation is going to be 4n plus 4s equals 376. They've both been traveling 4 hours. Our variables n and s represent their speeds, and we know the distance is 376 miles. One train is traveling 10 miles faster than the other. So because it doesn't specify which train that is, whether or not it's the northbound or the southbound train, you can really pick here. I'm just going to go ahead and pick the northbound train. So the northbound train is traveling 10 miles per hour. It should say miles per hour faster. So that's going to be 10 plus s. So another problem set up for substitution. So I'm going to take my 10 plus s, plug it in for n in my first equation. So we're going to get 4 times 10 plus s plus 4s equals 376. Distribute into the parentheses. 40 plus 4s plus 4s equals 376. We get 40 plus 8s equals 376. Minus 40. We're going to get 8s equals 336. Then we're going to divide by s. Sorry, 8. Sorry, we're going to be dividing by 8. So we're going to get that the southbound train is traveling 42 miles per hour. My northbound train, because it's traveling 10 miles per hour faster, is going to be traveling 52 miles per hour. Okay. It is important that when you are doing word problems associated with systems of equations, that you do include units on your answer. So the last answer was feet. This answer is in miles per hour. So whatever your units may be, you need to make sure you're using them. So next we have an example using money. A group of neighbors went to a play. There were 10 more adults than children with a total paid admission of $620. If the adults paid $12 and the children paid $8, how many adults and children went to the play? So I'm going to let A be my number of adults. I'm going to let C be my number of children. So in this case, I know a total of, I know that there were 10 more adults than children. So the number of adults was 10 more than the children. So 10 plus C. I also know information about money. So $12 per adult plus $8 per child gives me the total $620. So again, going to be using substitution. I'm going to take the 10 plus C and plug it in for my A. So 12 times 10 plus C plus 8C equals 620. And distribute. 120 plus 12C plus 8C equals 620. Combine like terms. 120 plus 20C equals 620. Subtract 120, get 20C equals 500. Divide by 20, C is 25. So now my adults, because there were 10 more adults than children, my adults are 35. And because I want to have units, I'm going to say 35 adults and 25 children. Last problem, we are going to look at a problem with only money. So a fourth grade class contributed $17.70 in dimes and quarters to the Red Cross. In all, there were 96 coins. Find the number of dimes and quarters that the children contributed to the Red Cross. So I'm going to let D be my number of dimes and Q be the number of quarters. So, important thing to know here, how much is a dime and how much is a quarter worth? That's gonna go for my money equation. So, a dime is worth 10 cents. So, I'm gonna have 0.10D plus quarter is 25 cents, so 0.25Q equals the amount of money that they donated, $17.70. That's my first equation. The second thing I know is that there were a total of 96 coins. So however many dimes and quarters I have, so D plus Q has to equal 96. So all of the examples we've done up to this point have been set up for substitution, which is very common. But this case, I'm going to use elimination to solve. So I'm going to, you can choose to eliminate the D or the Q first here. It doesn't matter which. I'm going to go ahead and eliminate D. So if I want to eliminate D, I need to make sure that they are both a 0.10. So I'm going to multiply by 0.10. And one of them has to be negative. So I'm going to multiply the bottom equation by negative 0.10. So my first equation is staying the same. My second equation is going to be negative 0.10D minus 0.10Q equals negative 9.6. When we add together, the 0.10 and negative 0.10D are going to cancel. So then 0.25 minus 0.10 is 0.15Q. And then 17.7 minus 9.6 is going to be 8.10. Divide by 0.15. And Q is 54. Now the easiest way to solve for D in this case is to use the fact that D plus 54 equals 96 and go ahead and subtract 54. So we're going to get that D is 42. So we have 54 quarters and 42 dimes. Let me know if you have any questions about identifying the variables for a system of equations, word problem, or setting up the equations, or solving using substitution and elimination.